This is the lab portion of the lesson. We'll take a look as it's applied within Unisphere, some of the common VNX terminology that we went over. So we'll log into the Unisphere. One of the first things that we'll look at is the ALUA-based settings. So asymmetric LUN unit access, logical unit access. We'll take a look at where you actually set that. So if we go to the array itself within this first dashboard we see, and we right click and we go to connectivity status. This is going to show us our initiator records, our hosts that are actually logged into the array itself. Okay. And initiators, you're going to see multiple initiators assigned to a host. Now these hosts in particular, they're ESXi 5 hosts. So when they log into the array itself, they automatically self-register. Okay, and they pull the host name from the host directly, and they log that in this entry. Most often when you're doing the zoning and you're zoning a host to the VNX or the CX series, the registration does not take place automatically. Now the caveat to that is if you have a Unisphere client on the system that's actually connecting, it will register what the name of that host is and what the IP address of that host is. More times than not, if you don't have the clients on there, it will not self-register and you'd have to go in and manually register. But this is a ESXi 5 host, so we don't have to worry about that. But if I take a look at the initiator record itself and I go to edit, you'll see a couple different things here. Now, I could edit this initiator if I wanted to, but I'm not. I'm going to show you a couple different bits of information here as it applies to this record in general. Now, you could go in here and set the different initiator type, and more times than not, Clair Open is the primary initiator type that we're using in most environments. You also see recovery point in here. So if we're doing a recovery point installation, the initiator records need to be recovery point appliance. But most often, and what's common in a lot of the environments that we see is that Clair in Open is usually the initiator type. And then failover mode is failover mode 4. Failover mode 4 is ALUA. It is ALUA based. It gives you this non-optimized and optimized pathing if there's issue with an owning SP for a given LUN. That is by default. That was the first option there. That's the one it selects. So that's what you would want to use if you're running a VNX and you're zoning to the VNX for a host. You would want to use ALUA. There are some caveats to that, but more times than not, ALUA is the route you want to go. How I would tell that for a given initiator that it's already logged in, if I clicked on the initiator itself, hit detailed, I could see that the failover mode here is 4. So I know this is configured for ALUA. Now, if for some reason I logged in and the initiator failover mode was set to 1 and I wanted to change it to 4, well, this would be how you would do it. Come over here, you click on the array itself, go to host, go to failover wizard, and this little wizard right here with wizard and all will allow you to change the failover mode from its given whatever it's currently set to as far as the failover mode, and will allow you to change it to whatever you want. So for instance 6, I could go in here, select vSphere 6, hit next, select the array, next, and then you'll see the same information that we were presented with on a couple previous screens. So I could change the initiator type to Clarion Open, could change the failover mode to 4 or any other failover mode I wanted to. And then I can set the array COM path, which is enabled by default. It was actually an advanced setting on the previous screen. You didn't see it. And then you go next, and then finish, and then that would change the initiator records for the given host. Now, if it's an ESXi server, I would recommend throwing it into maintenance mode, then running this, and then either rebooting it or removing it from its current storage group, which we'll go over here in a second, the LUN masking piece, and adding it back into the storage group. And this will change what's called the SATP, the storage array type plugin within ESXi itself. And it's going to be how it actually handles failovers. Can't remember how the terminology for some of the SATPs, but it's like VNX underscore SATP VMW or something like that. It changes the SATP and it changes how it actually handles failover within the PSA or the pluggable storage architecture within ESXi. So we'll hit cancel here, hit yes. We'll move into the front end and the back end. Where you can view that information is under System, and we'll go to Storage Hardware, which denotes block storage hardware. And if I go to SPs, kind of drill down in here, it's just a multi-click process. I can see that I can see my slicks in here, my A0 and A1, and if I go to Properties for this, I can see that this is a fiber channel slick. It's got 4 ports. They're actually negotiating at 4 gigabit for whatever reason. The max is 8 gigabit. I can also see how many logged in initiators that I have. Okay, so these are hosts that are actually logged into the front end ports on this array themselves. Now this is your fan-in ratio. How many ports are coming into one port on a VNX? And each of these guys are going to have different fan-in ratios or different registered initiators on here, if there's any host zone to them. So this one is. This one does not. And I would assume this one does not either. So that gives you some fan-in ratio. Then I can, if I want to look at the actual SAS backend information, not too much to really show you here, but if you wanted to see, the SAS controller, let me scroll down. This would be presented here. So if I go and I right-click here and I hit Properties, I'll see that the current speed is 6 gigabit per second. I know that this is my connector for the SAS backend bus. So not too much information to show you there. You can find a lot of this information if you're running reports and you want to view your slicks and things of that nature. You can view that via the reporting rather than having to drill down in here and take a look at that. The vault drives will be just as exciting. It's not really much I can show you there. If I go to Storage Pools, go to RAID groups. Now it really depends on how you've been taught. If you're currently a user of a VNX or a CNX, some person maybe along the way, whether it was a vendor or whether it was EMC themselves or a VAR or someone, they may have said, never use the vault drives for anything. It's just never do it. Don't even configure a RAID group. Well, in most situations, that's okay. You could do that, but as these drives get bigger, and maybe you've allocated 600 gig drives for the vault drives, maybe you want to utilize that space for something, and you certainly can. There's nothing preventing you from doing that. Now, you will lose some capacity off those drives, that 192 gig off each drive that's utilized for your vault cache and the VNX OE itself. That is going to be stripped away. You won't have that space allocated to it. You won't even see it in the GUI. You don't even see it in Unisphere. But you could use that space if you wanted to, and that's what we've done here. If I look at RAID group 0, and I take a look at the disk, I know that the first 4 disks are my vault drives. Right, so I've got bus 0, enclosure 0, disk 0 through 3. I know those are the vault drives. A great use of those drives are boot LUNs. So if you're doing UCS and you're booting ESX from a boot LUN off the VNX, those are great locations. Those vault drives are great locations for those boot LUNs. Now it's only 20 gig. I mean, per host is typically what we configure it for. Sometimes smaller, sometimes bigger. But that's really all the space that's utilized. And if you're doing any ISO, if you have an ISO data store, maybe even a template data store, I mean, I know that may be precedent for some of you guys. But that's certainly a good use of that capacity that's built into this that you would maybe normally utilize in that RAID group. Next is the storage groups. We'll take a look at the storage groups themselves. So if I go here to host, click on storage groups, this is the LUN masking portion of the VNX itself. So LUN masking is really you're allowing certain hosts to see certain LUNs. That's really what you're doing, and to not see other LUNs. So what we've done here is, actually let's take a look at 6 and 7, is that we've allowed 6 and 7, host 6 and 7, to have access to, read-write access to, 4 LUNs. Those are data store 1, 2, and 3, and its boot LUN. Okay. Anything that I put, when I go in here and I register the hosts, and you saw that back on that connectivity status screen, which is right here, I can actually get to it, or at least a portion of it from this perspective. And I can see my initiator records. Once I actually register that host, or he self-registers, EasySXi5, If he self-registers, I can then throw him in this storage group, and then I can create some LUNs and put the LUNs in the storage group as well. That is your LUN masking portion. You're saying this host, vSphere 6, is able to see these LUNs, and only these LUNs. So if you want him to see anything outside of the LUNs that you've presented, you have to add that LUN to this storage group. You have to. You can't have a host, and one of the great rule of thumbs for storage groups is that you can't have a host in multiple storage groups, but you can have a LUN in multiple storage groups. So keep that in mind. So these data stores, 1, 2, and 3, they're in multiple data stores up here. See? So keep that in mind. A host can only exist in one storage group at a time, but multiple LUNs can exist in multiple storage groups. Now let's look at traditional array groups and storage pools. We go to storage here, and I click on storage pools. I've got two tabs up here on the left, and they both delineate what they are. The first one in the default to which it opens to is the pool tab, and this is where you would actually create pools. Now if I hit create here, I have the ability to create pools. So here's where I can go in and I can set the pool name, whatever I want that to be, the RAID type. RAID 10, yes, I said 10, 5 and 6. And then I can set different levels of disk performance within the pool itself. So if I have some SSDs, I have some flash drives, I could select those right there. I could select some SAS disks, some Nearline SAS. I think that's all I have left is Nearline SAS. And then I would go into manual, set it to manual, go to select, and then I would be able to select my drives that I want to add to this pool. So let's just add a couple. Let's add in all of them. We won't actually create it. So I've added my disk down here. So now once I hit apply down here, it's going to go out and it's going to create the storage pool. Now this is going to be a 4+1 RAID 5 storage pool. So I've essentially got 4 disks for data capacity, and then I've got 1 disk for parity. It's actually, the parity is actually spread across all the disks, but for the instance of an example, that's how it is. I can also put a pool description on it. I can set a threshold so that when it hits 70% full on the pool itself, it'll actually send me an email. And I can also enable fast cache. So if you remember, fast cache is this secondary tiering option that allows you to utilize flash disks within your array itself. It is enabled at the global level. The difference between enabling fast cache on pools and RAID groups is, from the pool perspective, you enable it at the pool level. You can't enable it on a per LUN basis. Now you can enable fast cache on a per LUN basis if it's in a traditional RAID group. So keep in mind that if you're designing, you don't have the option of enabling fast cache on a pool LUN basis. It's only on a per LUN basis in RAID groups. We'll go back over here. So the last thing I would do is hit apply. It would create the pool. We're not going to do that right now, but that would be the option there. I can also set a scheduled auto tiering. This would be the fast portion, giving you the ability to tier between different levels of disk types here. Normally you would not turn on auto tiering if you only have one type of disk in there. Then I think that makes sense. But if you did have multiple disks within this pool, you could turn on auto tiering, and then at a predefined time in the day, that data would be moved to specific tiers based on performance that's been captured throughout the day. That's it there. Let's jump over to RAID groups. You try to create a RAID group. Same type of process. You would go to create a RAID group. Remember, as I mentioned in previous slides or lessons, that a RAID group is maxed at 16 disks. You can't put any more than 16 disks within a RAID group. Okay. Now pools, you can put hundreds of disks in the storage pool, depending on the model of array itself. So if I wanted to create a RAID group here, same wizard, except you'll see that it switches when I switch between pool and RAID group. I can give it a number. I can't give it a name. It's predefined as to basically it's called RAID group, and then the number is the suffix on the end there. And then the RAID type, I can set that as well. I can do RAID 1, 1+0, or RAID 10. Yes, I said 10. RAID 3, RAID 5, 6. I could do just a single disk if I wanted to. or I could do a hot spare as well. So let's say I wanted to, same process, I want to put all these disks in here. I have all my disks around there. It gives me a recommended number. And the nice thing about Unisphere, when you're doing pool creations or RAID groups, that gives you the recommended number of disks based on the RAID type that you've configured. You can't change that. So if I set 10, you notice it goes to invalid disk selection because I don't have the recommended number of disks in the RAID group that it would like to see. I'll just flip through some of these other ones here just so you can see that. RAID 6, RAID 10, invalid disk selection. If we jump over here to the advanced options, there's really nothing over here that you need to do. There is some additional options where it can automatically delete the last LUN or automatically delete the RAID group after the last LUN is deleted. I typically would not set that. I mean, just personally. There's also RAID group power settings. You can allow power savings to be captured on this RAID group as well. And what I think this is the ability to be able to spin down drives if they're not accessed over a certain amount of time. We'll cancel that. So that's storage pools. That's some of the options there for storage pools and RAID groups. We'll also look at LUNs. So we didn't, really what you care about most likely, and what your applications and your server admins and your clients and everybody out there is that capacity. You usually have an application on a host. The host needs some level of capacity to be able to read and write its data. So to be able to do that, you need to offer up a LUN, which is a logical unit. To be able to do that, you jump either on the pool itself. So I would go over to the pool, I'd right click on it, hit create LUN. And then this would be how you would create a LUN, a slice of this pool, to be able to divvy off to a host that's connected to the array itself. Now, if I'm right clicking and hitting create LUN on the pool itself, it's going to take the properties of that pool for a lot of this information up here. So it's saying, all right, this storage pool type is a pool. Okay, we know that because I right clicked on the pool. The RAID type is RAID 5. All right, we know that because it's a RAID 5 pool. And then the storage pool for the new LUN, yes, it's going to be pool 0 because I right clicked on pool 0. So it's giving you information that's already predefined. Gives you available capacity, consumed capacity within the pool itself. Here are where you're going to actually modify the settings to create this LUN. So you can do a thin LUN or not. You can set the user capacity, so I could set it to 1 gigabyte. I could set it to terabytes, megabytes, terabytes, or even blocks. And then I could go in and set the LUN ID as well. And then I can do automated creation of LUNs here. So I could set it to 10 or 17 or whatever I wanted to. And then if I change that number to anything other than 1, it's going to allow me to assign a LUN name to each one of those. So I could say test LUN, test LUN, leave it at test LUN, and then I create 17 LUNs. They'll all have the name test LUN, and I'll set the starting ID to 1. And then it's going to increment each creation of those LUNs by 1 digit. So the first one will come out will be test LUN _1. The next one will be test LUN _2, and so on and so forth. Or you can just automatically assign names and then go back and click the properties for the LUN and then change the name yourself if you wanted to. Very useful command, especially if you're creating a lot of LUNs all at once. Advanced, these are alignment. You may have heard of disk alignment options where you would want to align the disk so that it is on a boundary that it doesn't allow multiple writes to occur on the back-end array. You used to have to use diskpart and diskpar to be able to align the LUN itself. When you actually allocate it to a Windows host, you would go and use diskpart, and you would align that LUN so that all writes that occur on that LUN itself are not actually creating 2 writes on the back end. With Windows 2008, that's changed. It's now configured, I think, with a 1 meg offset automatically when you create LUNs, so you don't have to worry about going in and using diskpart and diskpar, or diskpart, excuse me. In previous version it was diskpar. You don't have to go in with diskpart and actually set that. If you're configuring LUNs within vCenter for an ESX server, that's done automatically. So it is stripe aligned when you're configuring within vCenter itself. The default owner here is set to auto, so it is going to do a round robin approach. It does not take into consideration how much load you put on a LUN. So it really is LUN A goes to SPA, LUN B goes to S2B, LUN C goes to SPA. Bad example, I know, but that's how it happens. Just bounces back and forth between the SPs. The tiering policy here, and this is an older tiering policy on VNX OE32. There are some additional options here. This one has not been upgraded, but it does show you the basics here. It does show you that it is an auto tiering policy, or you can set it, you can pin it to the highest available tier if you wanted to. Auto tier will actually, I believe, pin to the highest, and that's what's available in the newest version of VNX-OEs. It'll auto tier, but it'll pin to the highest, and then it'll trickle down as it needs to the other tiers. So that's it from a LUN perspective, logical unit. Compression and deduplication, I can't necessarily show you those options from this perspective, at least from the block perspective. Now you can compress on the block side. Let me see if that enabler is available here. So if I go to RAID groups and I go to the LUN itself, yeah, it is actually. So yeah, if I go to the LUN itself and I go to the compression tab, I can turn compression on for a block-based LUN. I've never utilized this option from the block-based perspective simply because it's meant to be used for data that is not in use. Simple as that. You don't use it for LUNs that are actually being accessed with any kind of regularity. It is more of a, my data is at rest, I want to turn compression on for these LUNs, here's how I do it. That's somewhat different on the file side. Let's see if we have those options available on the file side for us. So we'll go here, we'll go storage pools for file, and we'll take a look at this storage pool. And I was going to try to show you and see if deduplication and compression was actually enabled within this pool itself. But it is not. It's actually enabled on the file system. So my fault. So we'll go to shared folders, CIFS, and we'll go to one of these file systems. And we'll take a look at a couple things here. Now, compression, really on the file side, compression and deduplication are somewhat one and the same. I don't believe you can set compression on a file system from within the interface itself. If you enable deduplication, it's going to compress those files as well. But this is where you would do it. It'd be on a per file system basis. So you can see right here, it is turned on. I believe it is turned off by default. And then it gives you some information down here, statistics. You know, file scan. It is an operation that takes place on a daily basis. It's not continually run. It's not as data is added that it dedupes. And there's things that have to be in play. There has to be certain access times or modified times that are recognized before it actually goes and dedupes those files, because you typically would not want your files that are being accessed with any regularity to be deduped or compressed, because it does add additional latency to that process. So that's where you would do it from the file side for a file system. The last thing I wanted to touch on here was hot spare, so we'll jump back over to the block side of the house. Go back to storage pools, and your hot spares are configured just like any other RAID group, except you're only selecting one disk, and you're selecting that RAID type as hot spare. So if I go in and hit create, we'll go ahead and create this, or attempt to create it. And I would change, we usually like to put our hot spares in the 200 range, but you could put them wherever you wanted to. I would change this to hot spare. I go in and manually select my disk. That. No need to set it in the advanced option. And then as soon as I hit apply, the disk will show up like this. Once I configure a hot spare, it's globally available to protect any disk that is the same drive type within the array. Another notion is it's got to be the same size or smaller to be able to protect it. So if I've got a 1 terabyte nearline SAS drive out there, I could use a 2 terabyte nearline SAS drive to protect that 1 terabyte drive. I couldn't do the inverse of that. I couldn't have a 1 terabyte drive protect the 2 terabyte nearline SAS drive. So you get the point. It's got to be the same size or bigger to be able to protect the drives on the array. You would also, as I mentioned, you would want to have hot spare for each drive type. So you'll see here I have a drive type for each type of disk, nearline SAS, and flash drive as well. So that's kind of it. That's kind of some of the terminology around the VNX itself. There are numerous clicks and links within this interface itself, which we just won't have time to go over in its entirety. That is the basis of things that I thought were most important when configuring and being in Unisphere itself. It is the Lua-based capability, something you would set when you're zoning in a host to the VNX itself. Your front end and back end ports all available through the reporting capabilities and where you would see that information. The vault drive, storage groups, the creation of traditional array groups and storage pools, all useful information when you're doing day-to-day administration. Your LUNs, it's the root of all. That is the essence of the VNX, right? That is what you're actually presenting out to the world, to your host in general. Compression and deduplication, these are space efficiency type technology. We took a little bit of a look at that. And then finally, your hot spares. That concludes this lesson of the lab. See you in the next lesson.